students, welcome back. So in this video we will discuss about the azeotropic mixtures. But before studying azeotropic mixtures, let us first understand the theory of fractional distillation. So what is this fractional distillation? It is the process of separation of one liquid from another having different boiling points by distillation. So this is known as fractional distillation. So information whether a particular solution of two liquids can be separated by distillation or not, that is provided by the study of liquid vapor equilibrium diagram at constant temperature. What does it mean कि like we are having the mixture of two solutions, क्या वो उन solution के component को, दोनों components को हम separate कर सकते हैं या नहीं कर सकते, इसकी information हमें कहाँ से मिलेगी? That is from the liquid vapor diagram. और separation possible है या नहीं वो हमें कैसे पता चलेगा? या तभी पॉसिबल है जब वेपर फेज की कॉम्पोजिशन डिफरेंट होगी from that of boiling liquid mixture. So separation is possible only when the vapor phase has composition different from that of the boiling liquid mixture. So this here we are having the liquid vapor equilibrium diagram for ideal solutions. So let us understand this liquid vapor diagram for ideal solutions. Suppose this side we are having component A which is 100% and component B is 0, means we are having this side A, pure A component, and this side pure B component, and A is 0. So this TA is the boiling point of the pure component and this TB is the boiling point of the pure component B. So this lower curve that shows the composition for the composition of both the components in the liquid phase, and this curve, this upper curve, that shows the composition in the vapor phase. So now suppose a solution of X is heated. X composition यहाँ पर अगर हम mark करें, suppose here is the solution with composition X and this is heated. When the temperature Tx, अगर हमने ये कॉम्पोजिशन का सोल्यूशन चूज़ किया है तो ये सोल्यूशन कहाँ पर बॉयल होगा? इट विल बॉयल एट टेम्परेचर Tx. सो एट दिस टेम्परेचर द वेपर्स कमिंग ऑफ, सो इसके विथ रिस्पेक्ट टू हमारे पास वेपर की क्या कॉम्पोजिशन रहेगी? दैट इज हेयर इफ वी टच दिस लाइन एंड composition will be x1. So x1 that is more towards B side, it means the composition in the vapor phase, that is B component is more in the vapor phase. So composition of the residual liquid will be richer in A as X is more towards A side, and the vapor phase that will be richer in the B component. So again let us choose one more composition. So let's B. Now let us take the new composition. Let's say it is Y. So the liquid now cannot boil at Tx. Now it will boil at different temperatures. So with respect to this composition, this liquid mixture will boil at temperature Ty. So this will require higher temperature as compared to Tx. That will be the vapors coming off at that Ty, that will be with respect to this vapor curve, and that will be Y1. See this side. So again that Y1 will be rich in B component. So the composition of the residue will be again richer in A. Thus if the process is allowed to continue, the boiling point of the solution will go on increasing towards A. The boiling point of pure A, लिक्विड प्योर ए, जैसे जैसे हम कॉम्पोजिशन जहाँ इससे चेंज करते जाएंगे तो रेसिड्यू की कॉम्पोजिशन, दैट इज रेसिड्यू इज रिचर इन ए एंड द बॉइलिंग पॉइंट विल रीच मोर टूवर्ड्स ए साइड. सो द which is the boiling point of the pure liquid. So at the same time the solution will become more and more richer in A. If the process is continued for a sufficiently long time, pure liquid A can be obtained. Now if the initial vapors are condensed and the solution obtained will have the composition X1. Now this solution with composition X1 will boil at temperature Tz. Now the distillate will be richer in B than before. If the process of condensation and redistilling is continued, the final distillate will be a pure component B. This way we are able to separate both the components A and B from their mixture. So now the next topic is azeotropes. So azeotropes, these are the mixtures of liquids which boil at constant temperature like a pure liquid without undergoing any change in composition. So whenever these azeotropic mixtures they boil, so they in the vapor phase also the composition of both the components that remain the same, and in the liquid phase that remains the same. So like in the previous diagram for liquid boiling point composition curves for ideal solution, we were able to separate components A and B because they were having different compositions in the liquid and the vapor phase. But in case of azeotropes, they have same composition in the liquid as well as in the vapor phase. So these are also called constant boiling mixtures. These mixtures, they have same composition in liquid and vapor phase. Again I am repeating, thus they cannot be separated into individual components. So previously also we studied that only the two components can be separated when they have different compositions in the vapor and the liquid phase. But these azeotropes, they have same compositions in the liquid and the vapor phase, so we are unable to separate the components in case of azeotropes. Next we are having types of azeotropes. So we are having two types of azeotropes: minimum boiling azeotropes and maximum boiling azeotropes. So minimum boiling azeotropes, these are formed by those liquid pairs which show positive deviations from the ideal solutions. The solutions which show positive deviations from ideal solution means they have more vapor pressure. So if they are having more vapor pressure, so less temperature is required to boil them. So at lower temperature they attain their boiling points. So that's why they are named as minimum boiling azeotropes, means they boil at lower temperatures from the boiling point of both the components. Same way we are having maximum boiling azeotropes. So these are formed by those liquid pairs which show negative deviations from the ideal solutions. Negative deviations from the ideal solutions means they form less vapor pressure as expected. So less vapor pressure is formed, so to reach at the boiling point, more and more vapors are required to attain their boiling temperature. So that's why their boiling temperatures, they are higher than the either of the components. So next point of distinction between the azeotrope is that, as we discussed already, such azeotropes, they have boiling points lower than either of the components, and these maximum boiling azeotropes, they have boiling point higher than either of the components. So reason we discussed it, that is based on the vapor pressure. Because now there are some examples of minimum boiling azeotropes and मैक्सिमम बॉइलिंग एजियोट्रॉप्स. तो सबसे पहले हम मिनिमम बॉइलिंग एजियोट्रॉप्स के एग्जांपल्स को डिस्कस कर लेते हैं. फर्स्ट एग्जांपल है मिक्सचर ऑफ वाटर एट इथेनॉल. सो जब मास परसेंटेज वाटर की 4.43 पे पहुंचती है, या इस मास परसेंटेज वाटर की जब ये मास परसेंटेज रहती है, तो एजियोट्रॉपिक मिक्सचर फॉर्म होता है. सो this is the example of minimum boiling azeotrope. So this can be shown here. So the boiling point of water is 373 and boiling point of ethanol is 351.3. और जो azeotropic mixture का boiling point है, that is less than the boiling point of water and the ethanol. Same way next example is here वाटर एंड प्रोपेनॉल. जब मास परसेंटेज वाटर की 28.31 होती है, सो रेस्ट ऑफ द मास परसेंटेज दैट इज ऑफ प्रोपेनॉल, देन इट फॉर्म्स द एजियोट्रोपिक मिक्सचर. सेम वे द बॉइलिंग पॉइंट ऑफ वाटर इज 373 एंड दैट ऑफ प्रोपेनॉल दैट इज 370. सो द बॉइलिंग पॉइंट ऑफ एजियोट्रोपिक मिक्सचर दैट इज 360.1. सो नेक्स्ट इज chloroform and ethanol. Mass percentage of chloroform when attains that this 33.01, तो rest, obviously rest is that of ethanol. Then same we can say that boiling point of chloroform, that is 334, and boiling point of this ethanol is 351.3. और जब एजियोट्रोपिक मिक्सचर बन जाता है तो उसका बॉइलिंग पॉइंट जो है वो 332.3 है. So we can see in all these examples the boiling point of azeotropic mixture that is less than the boiling point of the components. So the next example, one more example is here, that is of benzene and acetic acid. So 2% of ethanoic acid is there, then it forms the azeotropic mixture. Same way, let's see the examples of maximum boiling azeotropic mixture. So first one is the mixture of water and HCl. So same way, when the mass percent of A means water component, that is 79.9, 79.7, then it forms the azeotropic mixture and it boils at 383, which is more than the boiling point of both the components. Next is water and nitric acid. When 42% of water 42% जो मास परसेंटेज वाटर की अटेन हो जाती है, देन इट फॉर्म्स द एजियोट्रोपिक मिक्सचर. रेस्ट इज नाइट्रिक एसिड. सो इट बॉइल्स एज 393.5, विच इज़ अगेन मोर देन द temperatures or boiling temperatures of water and nitric acid. Next is water and परक्लोरिक एसिड. सो इसका भी जब 28.4% मास परसेंट वाटर की अटेन होती है, देन इट फॉर्म्स द एजियोट्रोपिक मिक्सचर. सो इसका भी बॉइलिंग पॉइंट जो है वो वाटर और परक्लोरिक एसिड के बॉइलिंग पॉइंट से ज़्यादा है. सो इन ऑल अगेन इन ऑल दीज 3 एग्जाम्पल्स द बॉइलिंग पॉइंट ऑफ एजियोट्रोपिक मिक्सचर्स that is more than the boiling point of their respective components. After the examples, let us study the boiling point composition curve for the minimum boiling azeotrope. So मैं इसको थोड़ा सा focus कर लेती हूँ so that it is more visible to you. So इसको पहले हम minimum boiling कर्व्स को स्टडी करते हैं, मिनिमम बॉइलिंग एजियोट्रोप्स की कर्व को स्टडी करते हैं. सपोज नाउ this side, if we consider the distillation of the mixture of composition X, the vapors given off at this X composition, so if we touch this the vapor curve, so it will be X1. So this will be the composition of the vapors, that is X1, and this composition with the distillation of this composition mixture, if we are considering at this time vapors given off will be having the composition X1. So the composition of the residual liquid will shift towards A, and in the meantime the composition of the distillate will shift towards composition C. So ultimately, by repeated fractional distillation, the mixture of C composition will be obtained as a distillate. और जो प्योर लिक्विड है वो हमें रेसिड्यू की फॉर्म में, जो रेसिड्यू रह जाएगा दैट विल बी द प्योर लिक्विड ए. सो द रेसिड्यू ऑफ प्योर लिक्विड ए विल बी लेफ्ट. सो इट विल नेवर बी पॉसिबल टू ऑब्टेन बी एज अ प्योर लिक्विड. सो अगर हमने इस तरफ से स्टार्ट किया तो हमें बी प्योर फॉर्म में नहीं मिल पाएगा. सो रेसिड्यू में जो बचेगा वो ए होगा. अगर हम कर्व के इस साइड से स्टार्ट करेंगे, सो अगेन let's have the mixture of composition Y which is distilled. So the vapors given off by distilling this Y composition, that will be X1, and see now this Y residual composition will be more towards V, and the composition of the distillate, that will be more towards C. So ultimately the mixture of composition C will be obtained as distillate and pure liquid B will be left as residue. So it will never be possible to have pure A. So again this at this C, इस तरफ से स्टार्ट करें तो हमें प्योर बी नहीं मिलेगा. इस तरफ से स्टार्ट करते हैं अगर हम मूव करना तो हमें प्योर ए नहीं मिलेगा. सो एट दिस कॉम्पोजिशन, इट मीन्स एट दिस कॉम्पोजिशन दे आर फॉर्मिंग द मिनिमम बॉइलिंग एजियोट्रोप्स. हम मिनिमम बॉइलिंग क्यों कह रहे हैं? क्योंकि ये हमारे पास बी का बॉइलिंग पॉइंट है और ये जो है वो प्योर कंपोनेंट ए का बॉइलिंग पॉइंट है। सो इन दोनों बॉइलिंग पॉइंट के नीचे जो ये सी बन रहा है, एजियोट्रोप्स बन रहा है, सो दिस इज लेस देन द बॉइलिंग पॉइंट ऑफ दिस टू। सो अगर हम एग्जांपल, जैसे हमने फर्स्ट एग्जांपल स्टडी की थी वाटर और इथेनॉल की एग्जांपल देखी है, वाटर और इथेनॉल की, और वाटर और इथेनॉल में से हमारे पास इथेनॉल का बॉइलिंग पॉइंट जो है, सपोज हम इसमें इथेनॉल C2H5OH इथेनॉल इस साइड पे लें, वैसे ही वैसे ए हमने बी और ए और बी तो हमने जनरल लेके समझा। सो अगर हम इथेनॉल और वाटर इस साइड पे लेते हैं, सो सपोज इन केस ऑफ इथेनॉल बी को इथेनॉल जस्ट कंसीडर करके देखें तो हमारे पास बी का बॉइलिंग पॉइंट ये रहेगा 351.3 और वाटर का रहेगा 373। सो बॉइलिंग पॉइंट ऑफ सी पे जो कंपोजिशन होगी, अगर हम मास परसेंट ऑफ ए के हिसाब से देखें, सो दैट विल बी द मास परसेंट ऑफ 4.43 ही मास परसेंट रहेगा ए का। अगर हम परसेंटेज के हिसाब से देखें या इथेनॉल के हिसाब से, तो लगभग हमारे पास 95% ए पे जो है वो एजियोट्रोप बनेगा। सो ऐसे ही हमारे पास बाकी जो एग्जांपल्स हैं, जो हमने बाकी एग्जांपल्स देखी, उनको भी आप इस तरह से लेके देख सकते हो। डिपेंड करता है कि किस तरफ कॉम्पोजिशन और किस कॉम्पोजिशन पे वो एजिटोप बनेगा, उस हिसाब से हम कंपोनेंट्स को यहाँ पर लगा सकते हैं। ए और बी तो मैंने जनरल दी है, सो दिस इज फॉर ऑल द मिनिमम बॉइलिंग एजियोट्रोपिक मिक्सचर्स। Same way, let us study the boiling. Let us study the boiling point composition curve for the maximum boiling azeotropes. So see this one, A is the pure component this side, B is the pure component this side again. So C, at point C they are forming the azeotropes. Now let us discuss it in detail. Consider the distillation of a mixture of composition X. हम X composition के mixture की distillation को study करें. So the vapors coming off at this point, at this composition, the vapors coming off that will be having composition X1. So the composition of the residual mixture that is towards C and the composition of the distillate that moves towards A. So similarly, this side the mixture of a composition lying between B and C, say that is Y. हम इसमें इस तरफ हम कर्व देखते हैं, तो this one. So let's now study the distillation of the composition mixture of composition Y. So on distillation it will give again the vapors which will be richer in this B, and this is the composition of the vapor phase, that is Y1. So the composition of the residual shift towards C and the composition of the distillate that will shift towards B. So it will never be possible to separate a mixture completely into pure component A and pure component B. So the composition of residual liquids that will shift towards C from both the sides. So again, if we see this at this composition, C will be forming the maximum boiling azeotrope. So if A is having this much boiling point, B is the boiling point of the pure component, and this C, the boiling point of C, that is higher than that of the boiling point of A and B. So you can consider again any of the example, like we considered so many examples, water and HCl. Let's have this example, water and HCl. So water and HCl जो है, that is 20.2% of HCl कंसनट्रेशन पे जब हमारे पास 20.2% HCl रह जाता है, तो हमारे पास क्या बनता है, एजियोट्रोप. सो अगर हम इस तरफ HCl लेते हैं, इस तरफ वाटर लेते हैं, तो व्हेन दिस कंपोजिशन दैट इज अटेन, दैट इज एट 20.2% HCl, so that as maximum boiling azeotrope that is formed. So this is all about the azeotropes and their types and the graphical study of this boiling point composition curves for minimum and maximum boiling azeotropes. So here I have written few numericals based on Henry's law and Rolle's law. So you solve these numericals and send me the answers in the comment box. We will discuss these numericals in our next video. So these are few numericals. Again, I am showing these four numericals based on Henry's law and Rolle's law, solutions of which we will discuss in our next video.